My name is Erik Jensen, and I have been skiing my entire life. That perhaps is not an unusual statement for this part of the world, with world-class skiing right up the road. But it was a little unusual where I grew up in central Connecticut. I don't remember learning to ski. I was too little. But I do remember spending tons of afternoons and evenings driving all over Vermont and New Hampshire to go to the slopes during my childhood. And honestly, part of the reason I still live in Colorado today is access to the slopes. However, it wasn't until a little over a year ago that I decided to take my first steps into backcountry skiing. For the uninitiated, backcountry skiing is, well, exactly what you'd think. It's not skiing at a ski resort, but skiing rather in the backcountry. You might be asking yourself, why would you possibly want to shuffle yourself up a hill in deep snow without the aid of a lift? Isn't the best part of skiing paying for your potential energy? Well, yeah, but the increased popularity of resort skiing, particularly in Colorado, and a desire to lower my road rage-induced blood pressure at what can be truly, truly horrible weekend ski traffic, has pushed me to search for other ways to enjoy the sport that I love. Not to mention, backcountry skiing is, of course, a great workout. Another added benefit to venturing off-piste is it's easier to find what is often affectionately referred to as the white room. The backcountry is significantly less ski just from access issues, and so finding untouched lines of glorious powder is easier. But untouched lines of glorious powder have this nasty habit of occasionally, and usually with little warning, turning into a deadly avalanche. Venturing into the backcountry is dangerous, and learning to recognize some weak snow conditions and what avalanche terrain is critical to reducing those risks. So, as with pretty much everything, knowledge is power. So I turned to where most people, at least in the States, turn to start their avalanche education: the Accredited American Institutes for Avalanche Research and Education, or AARE, and their course, AVI-1. Now, I've been talking for a few minutes, and I can kind of feel the audience here. Your collective question is, all right, this is a geotechnical engineering conference, what gives? Well, I also wasn't expected to be blindsided by geotechnical engineering either, while just sitting outside in Steamboat, Colorado, on a frozen log in my ski gear, listening to some grizzled old backcountry travel and recovery veteran. By the way, they don't call it rescue in avalanche circles. Teach me, maybe a mediocre geotechnical engineer, but, a doctor of geotechnical engineering nonetheless, granular mechanics. I'd never really thought about it, and this is, admittedly a little dumb, but of course, snow is a granular material. Relative to soil, it's just a granular material that happens to have a phase transition at temperatures the world experiences all the time. For snow, water is somehow even more important, as it, literally is water. And unless you're talking about glaciers, its layers aren't deposited on geologic timescales, which in my opinion, and hopefully you'll agree in a few minutes, makes it a really nice example to teach the basic physics of slope stability. I honestly felt bad for my teacher, because I was immediately and irresistibly compelled to start geo-nerding out. I mean, how could you not? Avalanches are traditionally analyzed as slope stability problems, with layers usually perpendicular to the slope of the ground. It uses names like basal and shear and strength. I was turned into that guy, answering questions with completely unnecessary detail and asking insanely detailed follow-up questions, which, my poor instructor, an expert, sure, in avalanche, reconnaissance, recovery, education, but, not a granular mechanician. There's no way I wasn't so annoying. So, despite my best efforts, we learned so much that day. You see, Colorado has some of the most consistently dangerous avalanche conditions in the world, earning the nickname Considerable Colorado, after the fact that conditions rarely decrease past considerable, until the spring, on the North American Public Avalanche Danger Scale. Colorado is at a relatively low latitude, which means that it gets more sunshine than most of the world's ski-centric mountain ranges, particularly on south-facing aspects. Additionally, the state has a continental climate, being on far inland from the Pacific coast and on the rain shadow side of the Rocky Mountains. Compared to the coastal Rockies, like nearby Whistler or down in Lake Tahoe, Colorado, it just gets less snow. But our mountains are tall. Some of the tallest in all of the Rocky Mountains. And so temperatures get colder earlier than the latitude would typically suggest. So, before diving into the specific problems facing the Colorado backcountry, not to mention the problems faced by Colorado Department of Transportation and other mountain municipalities, to reduce the dangers and economic impacts of avalanches, we need to take just a quick detour to the basics of snow shear strength. This is super and way oversimplified, but in general, it's all about temperature gradients and the resulting water vapor pressure gradients. So, first, throughout the winter, the snowpack insulates the ground such that the temperature at the ground to snow interface always sort of hovers around freezing. But critically, the temperature at the top of the snowpack is affected by, weather. These disparate temperatures cause thermal gradients to develop through the snowpack, and the smaller the snow depth, typically the larger or higher the gradients. Second, warm air holds more moisture than cold air, and therefore, water vapor pressure gradients develop with the thermal gradients. So, these gradients can act to either round snow layers, drawing moisture in, making them wetter, more consolidated, although it's not used quite the same way we use the term. And critically, it makes them stronger. Or this can act to facet snow layers, drawing water away, making them wetter, and making them weaker. So we're out in the middle of the snow, and then my class and I were asked to dig a snow pit. My goodness, if I thought that dig a snow pit, if I thought that my geotech brain was having fun before, it was having quite a bit more fun after this. So rather than explain to you, I figured I would just make a short video to show you what I mean. So here we go.
Hello, welcome to an overcast day here in Summit County, Colorado. We are about to do some backcountry skiing, so we're gonna go dig a pit first to see what the conditions are like under the snow. We're gonna use this slope right here, and should be fun. Let's go dig a pit. So here you can see we've dug a pit. It has snowed a lot here recently in Summit County, although we had a pretty brutal start to the season. Earlier in the year, we had some of the worst avalanche conditions in recent memory. So I'm sort of expecting to see some pretty gnarly layers here towards the bottom. So let's take a look. So we're gonna do an extended column test. This is, well, you'll see what it does. Here we go. This is gonna go. Ready? What do you guys, do you think I went?
The bottom didn't go.
There it is.
Oh, there it is. Yeah.
So that was 2.
Yeah, it was an N12. Actually, it's a decently solid little kind of mid layer here, but it is just faceted nonsense. Yeah, that is so weak. Cool.
As far as you 3 shots?
Yeah.
So in Colorado, the pattern typically goes like this. Early season snow, consistently cold and dry nights, and not enough snow to bury the weak layers and reduce the gradients, meaning the development of a persistent slab like you just saw on top of a very weak, faceted layer. The other thing I like about this is it turns out that geotech isn't the only field with a few kind of silly but ultimately useful field tests. The snow science folks even use the same term, blow count, and this version is even more dependent on what the operator ate for breakfast. So since my 2 days in the backcountry with the ARI folks, I've started reading Avalanche books, papers, accident reports, you name it. And in an effort to continue my education, I am, absolutely no expert. Everything I said should be taken with a massive bucket of salt. But my points are really these. One, never stop learning, because you don't know when you're going to find something that catches your interest. And two, you never know when your passions are going to intersect. And when they do, it'll probably not be where you expected it. I think every field can sometimes be a little guilty of navel gazing, though I like to think, I hope to think, that most geotechs do a pretty good job of recognizing the impacts of our work have on other disciplines. Perhaps being the foundation forces that perspective sometimes. But my experiences are a good reminder that fundamental physics are fundamental physics, and it's never too late to add some new perspective. It might help you, it might help someone you're teaching, but at the very least, it'll give you a new perspective and a deeper understanding of the topics you already know a lot about. So, thank you for your time, and I'll see you on the slopes.